Hey, you guys, it's Miss All Day. We're starting a new chapter. It's going to be chapter 9, transformation. So I'm going to talk a little bit about some terminology that you might need to know. All right, so basically, a transformation of a geometric figure is a function or a mapping that results in a change. All right, so let's write this down. Transformation is a mapping that results in a change in the position, the shape, or the size of the figure. Now, not all of them occur at the same time because we're going to learn about a lot of different transformations, and you'll probably remember some from 7th grade. All right, so when you play dominoes, you move the dominoes. You flip them, you slide them, you turn them. Each move is a type of transformation. Now, when you're playing dominoes, you can tell that the shape and the size doesn't change, but the position does. All right, so this is a certain type of transformation. If you go down to number 4, this is a translation. It's a slide. A transformation that maps all the points of a figure the same distance in the same direction. So an example of translation besides playing dominoes, in case you don't do that, it would be playing checkers or playing chess, where you're moving pieces. The size doesn't change, the shape doesn't change, but its placement changes. All right, in a transformation, the original figure is called the pre-image. That's the original figure. All right, the resulting figure is called the image. And to preserve distance means that the distance between any 2 points of the image is the same as the distance between the corresponding points of the pre-image. To preserve angles means that the angles of the image have the same angle measure as the corresponding angles of the pre-image. A transformation that preserves, right here, preserves distance and shape is called a rigid motion. Okay, preserves distance and shape. All right, identifying a rigid motion. All right, so we're going to look at the pictures over here on the right. And we see that the pre-image, that's the original one. If you want to put that until you get used to the terminology, that's the original one. All right, the image is the new one. This is the new one. So does the transformation at the right appear to be a rigid motion? So think about what has to be true about a rigid motion. The image and the pre-image must preserve distance and angle measures. So you might look at it and you say, well, all the angles look like they're all 90 degrees. Okay, so angle measure is preserved. All right, how about distance? The distance between the points. So let me give you an example. If this was point A, and this is called A prime, meaning A moved in a different location because we're calling it A prime. But this is point B. And if this is called B prime, look at the distance between them. The distance got greater. So if you look above, a rigid motion preserves the distance and the shape. Okay, well, the shape was definitely preserved, but the distance was not. Okay, the shape has to do with the angles. All right, and the distance has to do with length. So, does the transformation at the right appear to be a rigid motion? No, it is not a rigid motion. How could we say that? We could say a rigid motion preserves both distance and angle measures. Both. All right, let's look at the next one. This one is the got it problem in your book. Okay, so if you're doing the notes with me, you'll end up doing all the got it problems for section 9.1. All right, does the transformation appear to be a rigid motion? All right, look at the pre-image, which is an original. And look at the image, which is a copy. Has the distance between the vertices changed? No. Have the angle measures in the image changed? No. So, does the transformation appear to be a rigid motion? Yes. We'll say distance and angle measures were preserved, meaning they didn't change. The position is what changed. All right, let's look at B. This is still a got it problem. All right, the pre-image is the original. I'm going to put a smiley face in the original ones. All right, the image is a copy. So let's look at it. This is A. This is A prime. All right, this is B. This is B prime. All right, let's look at the distance. The distance looks the same. We can even add a C here and call it C prime. So what do you think? Does the transformation appear to be a rigid motion? Yes. I'm going to state it a little bit different this time. I'm going to erase some stuff so I can write. All right, the distances between the vertices and the angle measures of the image are the same as the pre-image, which remember, that's the original one. All right, so that was example number 2, which was the got it. All right, let's move on down. Let's look at this picture right here. A transformation maps every point of a figure onto its image and may be described with arrow notation. So I'm going to highlight this in green. Here's the arrow notation, okay? So you see it right here. I'm going to just trace it. That's letting you know that J was mapped onto J prime. K was mapped onto K prime. Q was mapped onto Q prime. All right, so that's arrow notation. Now the prime notation I've already showed you. Okay, it's kind of like an accent mark. It's not really like an apostrophe. An apostrophe curves. This is more of a straight one. It's sometimes used to identify image points. In the diagram below, K prime is the image of K. All right, and here's a statement right here. Triangle JKQ is mapped onto triangle J prime, K prime, Q prime. Okay, so the first, when I read it first, I actually said the second part. This is using the arrow notation and this is using words. All right, notice that you list corresponding points of the pre-image and the image in the same order as you do for corresponding points of congruent or similar figures. You got to do it in the same order because their angles didn't change here. The distance didn't change here. We just see that it got changed either by positioning in this situation. The size didn't actually get changed, nor did the shape. It's the positioning actually got reflected, didn't it? All right, go ahead and go to the next page if you're following along with notes. If you're following along in the book, this top part here, the terms were on page 545, and then starting with identifying rigid motion, that was on page 546. Okay, and then I'm still on page 546 right here where it says naming images and corresponding parts. So this is page 546. All right, and in your book it'll say problem number 2 because it's the second type of problem, or kind of like a second concept within the whole big concept. All right, naming naming images and corresponding parts. For examples 3 and 4, in the diagram, EFGH maps onto E prime, F prime, G prime, H prime. So we're not having to figure out if a rigid motion was used. They're telling us that EFGH is mapped onto E prime, F prime, G prime, H prime. So they are, if you put them right on top of each other, their shape and their size didn't change. So what we want to know, E prime, F prime, G prime, and H prime, that's a copy of the original. Remember, the original is called a pre-image, and a copy of the original is called an image. So right here, when it asks us what are the images, we're looking for the copy. We're not looking for the original. So think about it. I mean, this is pretty simple. Look over there. What's a copy of angle F? It's F prime. Okay, so angle F prime. And what are the images of angle H? All right, well, here's H, and so here is its image. So that's going to be angle H prime. Makes sense, right? What are the pairs of corresponding sides? Now, this is the part that really you should feel pretty comfortable with because we've done this before. When it says the pairs of corresponding sides, they want us to list the sides. So basically, you're saying the EF right here corresponds to E prime F prime. E prime F prime. All right, let's do another color. FG, segment FG, corresponds to segment F prime, G prime. All right, and then we'll do the GH. Segment GH corresponds to segment G prime, H prime. All right, and then EH, segment EH corresponds to segment E prime, H prime. All right, so those are the pairs of corresponding sides. All right, now down here where it says example 5 and 6, these are the got it problems. These are the got it problems 2A and 2B. The ones up here were the got it problems 1A and 1B. Okay. All right, we're going to go back down here. In these examples, in the diagram, we're looking at this picture I'm circling in blue, triangle NID is mapped onto triangle SUP. Now you notice this time they didn't name it using N prime, I prime, D prime. They just named it using other variables or letters, and that's fine. There's nothing wrong with that. You can do that. So what they want to know here is what are the images of I, angle I. So here's I. Now, if you can't tell in the picture, go back here. I'm going to erase a little bit above so you're seeing exactly what I'm pointing to. If they want to know what corresponds with I, you're going to go to the middle here. So the image of angle I is mapped onto angle U. All right, and if you want to know point D, if you can't tell by looking at the picture, then look here. Point D is mapped onto point P. All right, that's example 5. Let's look at example 6. What are the pairs of corresponding sides? So why don't you pause it and you go ahead and list the pairs of corresponding sides and then just check back in just a minute and see if you have the same ones. So NI corresponds to SU, and ID is mapped onto UP, and I'm going to call it ND is mapped onto SP. So those are the corresponding sides that you should have gotten. All right. Go ahead, if you have your textbook open, turn to the next page. It's page 547 if you want to know kind of where we're at in the textbook. So they have this big box up at the top in the textbook. So I just copied and pasted it here. So we're just going to go over this. I'll highlight in pink. A translation is a transformation that maps all of the points of a figure the same distance and in the same direction. So you look over here, you write the translation that maps triangle ABC onto triangle A prime, B prime, C prime. Okay, if you're going to show me that, okay, I'm going to still do this in pink. Triangle A prime, B prime, C prime. If you're going to show me that triangle ABC is mapped onto that, so kind of like this. Triangle ABC is mapped onto triangle A prime, B prime, C prime, like that. Okay? This is how it could be shown to you, with or without a picture, right here. Capital T means translating. Okay, so translation. I'm going to translate triangle ABC, and when I do that, I come up with triangle A prime, B prime, C prime. Okay, that's how it's written. That lets me know I'm translating something, okay? A translation is a rigid motion that follows the following properties. So right here, this is what we just got finished writing. If I translated triangle ABC onto triangle A prime, B prime, C prime, then this is what we would know. All right, so I'm going to erase this so you can see exactly what I'm talking about. I'll do this in green neon. The distance from A to A prime equals the distance from B to B prime equals the distance from C to C prime. All right, so that preserves distance. All right, another thing. Segment AB is the same distance as segment A prime, B prime. Segment BC is the same length or distance as segment B prime, C prime. Segment AC is the same length as segment A prime, C prime. So distance is preserved yet again with segment lengths. All right. And then the measure of angle A right here is going to be equal to the measure of angle A prime. The measure of angle B equals the measure of angle B prime. The measure of angle C equals the measure of angle C prime. All right. So that explains the picture. It explains the new way to say that you're translating one shape onto another. And then this is the explanation of what happens. All right. All right, this is another picture that is also on page 547 in your textbook. Picture is worth 1,000 words. Just going to go over it a little bit. The diagram at the right shows a translation in the coordinate plane. Each point of ABC is translated 4 units right and 2 units down. So I want you to look at this for a minute. Here's A. It goes 1, 2, 3, 4. 4 units right. And it goes 1, 2 units down. That's where I mapped it from. Now they showed you B. I was showing you a different one. B goes 1, 2, 3, 4 units right and 1, 2 units down. It tells you specifically what you do. The easiest way to translate on a coordinate grid is to translate your vertices. If you translate the vertices, this is really, really easy, okay? Now, here's how you show that this coordinate right here for A, I'm going to call it XY, okay? I'm going to say A's coordinate is XY, and you can figure out what it is. It's -1, -2, -3, 3. It's really -3, 3, okay? What are you doing to that pair? You are taking ABCD. We don't have to call it a square ABCD. We don't have to call it a quadrilateral. We can just list ABCD. Okay, so ABCD is being mapped to, and this right here tells you what they're doing. They're taking the X and they're moving it 4 spaces to the right. They're taking the y and they're moving it 2 down. All right, so watch this. I'll do this in pink this time. Whoops, sorry. I'll do this in pink. If you take that point right there and you add 4, like it's saying right here, -3 plus 4 is what? All right, oops. I don't know what all that is. A prime equals. It's going to be 1. Now, if you take that y, and if you minus 2 from it, right here in pink, minus 2. What's 3 minus 2? 1. Look at this point right here and see if it matches that. 1, 1. Cha-ching. Okay, so there's several ways you can tell me how to do this. You could tell me, I'm going to erase some of this. I'm going to use blue. You could tell me, move it 4 units right and 2 units down. Okay, or you could use this format. Take the x and add 4 to it, and take the y and subtract 2 from it. Okay, now I'm going to show you what function notation looks like for this problem. It's right here. If I'm going to translate, I take the numbers for the x plus 4 and the x minus 2, and I take the 4 because it's positive and I put it first. That lets me know that's what I'm going to do to the x. Since I know there's really a plus sign in front of it, I'm going to add 4. All right, and then I do a comma and a minus 2. All right, that matches the y minus 2. That tells me that's what I'm going to do to the y. I'm going to subtract 2 from it. All right, so let me erase so you can see exactly. I'm going to say I'm going to do a translation. I'm going to do 4 units to the right and 2 units down. What am I translating? I'm translating A, B, C, D. Okay, and when I translate it, it's going to turn into A prime, B prime, C prime, D prime. Okay, and there's the picture of it. The 4 represents the translation of each point of the figure going horizontally. Okay, and the -2 represents the translation going vertically. All right, now we're still on the same page in the book, but we're flipping the page in the notes. Finding the image of a translation. What are the vertices of translating 2 to the left and 5 down of triangle PQR? All right, so the first thing we're going to do over here, because we don't have this picture right here in that diagram, we're going to go graph that first. We're going to graph the original. So how are we going to do that? Okay, well, let's do some points. P is 2, 1. So let's go graph that one first. 2, 1. That's P. All right, Q is 3, 3. Okay, 3, 3. That's Q. All right, R is -1, 3. -1, 3. All right, this is our original. It's called our pre-image. All right, graph the image of triangle PQR. All right, so I'm going to do this in red. I want you to write this. I'm going to take P prime. I'm going to take the 2, and I'm going to subtract 2 from it. I'm going to take the 1, and I'm going to subtract 5 from it. And we're going to get our point. 2 minus 2 is 0, and 1 minus 5 is -4. All right, let's go plot that. We're going to go 0, and then we're going to go -4, and that's P prime. All right, let's do R prime. All right, we're going to take the -1, and we are going to subtract 2. We're going to take the 3, and we're going to subtract 5. So -1 minus 2 is -3, and 3 minus 5 is -2. So -3, -2. So -3, -2. That is R prime. All right, the next one we're going to do is obviously Q prime. All right, going to take the 3. What are we going to do with it? Subtract 2. We're going to take the 3. What are we going to do with it? Subtract 5. So 3 minus 2 is 1. And 3 minus 5 is negative 2. So that's going to be 1, negative 2. And that is Q prime. Connect your dots. You just did a translation. Let's put what translation you did so you get used to doing this. Put capital T, negative 2, negative 5, and you did this to triangle PQR, and you ended up with triangle P prime, Q prime, R prime. That's what happened in green. All right, let's move down to the other one. What are the vertices? This is your got it problem in your textbook. This is problem 3A. Okay? What are the vertices of the translation of 1 unit to the right, 4 units down of triangle ABC? All right, so first of all, we're going to copy triangle ABC first. All right, so let's see. A is negative 2, 2. All right, let's go do that one. Negative 2, 2. That is A. All right, B is 1, 1. All right, 1, 1. That's B. All right, C is 0, negative 1. 0, negative 1. Let's see. All right, connect your dots. A little bitty triangle, right? See if I can make that look a little better. Sorry, I don't have a ruler. It's a little better. All right, so next thing we're going to do, we're going to do A prime, and we're going to do B prime, and we're going to do C prime. We're going to show our work. I'll do this in red. All right, so I'm going to take negative 2, and I'm going to add 1 to it. I'm going to take positive 2. I'm getting these down here. And I'm going to subtract 4. So negative 2 plus 1 is negative 1. And 2 minus 4 is negative 2. So let's go plot that one. That's negative 1, negative 2. And that is A prime. Put it right up here. All right, B prime. We're going to take 1, and we're going to add 1 to it. We could go ahead and put that, couldn't we? 2. We're going to take 1, and we're going to subtract 4 from it. It's negative 3. All right, let's graph that. 2, negative 3, and that's B prime. All right, now we're going to do C prime. We're going to take 0, and we're going to add 1 to it. It's going to be 1. We're going to take negative 1, and we're going to subtract 4 from it. And that'll be negative 5. So that's 1, negative 5, and that's C prime. We're going to connect our dots. And we translated it. Let's write this just for practice. We translated 1 unit right, 4 units down. We did it to triangle ABC, and our result that we got was triangle A prime, B prime, C prime. It was a rigid motion because the distance and the angles were preserved. All right, let's go ahead and go down to writing a rule to describe a translation. There's a lot in this first chapter. All right, writing a rule to describe a translation. What is the rule that describes a translation that maps PQRS onto P prime, Q prime, R prime, S prime? All right, so what we're going to do is we're just going to look. Okay, if I took this P and I end up with it here, tell me, count how many you go to the right. Okay, so what you do is you pick a point. Pick a point. That's your first step. So I'm going to pick -3, 4, which is point P. -3, 4. All right. The second thing you're going to do is you're going to map it to P prime. Okay. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So I went 8 units right. And I went 1, 2 units down. All right. Third thing I do, what did I do to the X? I went right 8. So it's going to be a +8. All right. What did I do to the Y? I went down 2. So it's going to be a -2. All right. Now we're going to write our rule. We translated 8 to the right and 2 down. What did we translate? We translated P, Q, R, S. That's our answer. All right, this next example in your textbook, both of these are on, let me put this up here, page 548. Okay, this example number 10 is your got it problem number 4, just so you know. All right, the translation image of triangle LMN is triangle L prime, M prime, N prime, with L prime being this, M prime being this, and N prime being this. What is a rule that describes the translation? So this is working a little bit backwards, kind of, sort of. They're telling you where to put them. All right, well, let's go put them there. Let's put L prime at 1, -2. 1, -2. Right here. L prime. Well, you know what? We don't really have enough room to graph everything else. But if all they want to know is the rule, this is going to be easy. So I'm going to go right. How many spaces? Okay. We're going to map it. If you counted it, you should have counted 7. So 7 right. All right. And then I'm going to go down 1. Okay. And 1 down. All right. Now we're going to write that as a rule. I'm going to write the rule in blue. I'm going to translate 7 right means it's a +7. Always left and right goes first. That's your X, what you're doing to your X. Up or down always goes second. So down means -1. And what am I translating? I'm translating triangle LMN. And that's all they wanted was the rule. I do not have to finish graphing it. That is the answer. All right, I'm going to pause just for a minute. Be back. All right, I'm taking a little side street for a minute. If you go into ClassLink and you click on Pearson, I'm going to show you where you can go in case I don't do a lesson every day for each section. When you go into Pearson, you're going to click on your geometry book. It has like the bee looking thing on it. And it's going to take you to a page kind of like this. All right, so you're going to go down to chapter 9 where it says transformations. And we are in 9.1. If you wanted to go here to work through your problems, you can. Right here, identifying a rigid motion, naming images and corresponding parts, finding the image of a translation, writing a rule, and composing translations. We've done problems 1, 2, 3, and 4. I'm going to click on composing translations just to kind of show you that it kind of walks you through it. So if you're struggling with like looking at the book, this is a place you can go. I don't know why it's not showing up, but normally it would show up for you. and you could go there and it would help you. Okay, I'm going to show you something else that you can do, because I want to show you an example straight from the book. I'm going to go to the geometry book. I'm going to go to the e-text. You only have the choice of clicking on the student edition, but that's all I want anyway. Making sure I was still recording. I'm going to see if it's going to pop up. I want to show you something. Go to the menu over here. I'm going to go to the table of contents. And I'm going to go down. Let's see, we're around page 540 something. I'm going to go right here. And we're going to go to page, I want to go to page 548. I'll go here, and I'm going to click the next button a couple of times. I want to show you a picture, because this will really explain this next part really well. All right, down here on the bottom, a composition of transformations. This is page 548. A composition is a combination of two or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. In the diagram at the right, the field hockey ball can move from player 3 to player 5 by a direct pass. This translation is represented by the blue arrow. The ball can also be passed from player 3 to player 9, and then from player 9 to player 5. The two red arrows represent this composition of translations. In general, the composition of any two translations is another translation. So think of the word as composition as in more than one step. Okay? All right, so now we're going to go back here to the composition of transformation, a combination of two or more transformations. All right, in the diagram at the right, it shows two moves of the black bishop in a chess game. Where's the bishop in relation to its original position? All right, so first of all, its original position right here. Okay, he moved here. All right, everybody see that? That was his first move. All right, so we're going to use 0, 0 as its beginning. Okay, so we're going to say 0, 0 is where he began. That's the starting point, okay? We're just going to let that be coordinates. All right, the first thing we want to do is the bishop moves. Let's see where the bishop moves. In order to get to this position here, the second blue position, okay, I have to go left or right first. We know that in real life he goes slanted, but we're pretending like we can't go slanted. You want to describe the move, tell me where he moved X way and where he moved the Y way. So that's 1, 2, 3, 4. So he went 4 squares right. All right, and then 1, 2, 3, 4. Okay, he went 4 squares down. Okay, so that would look kind of like this. Let's do this in green. He was translated. He went 4 right and 4 down. Okay, what was being translated? Well, it was actually the point XY, which we called it 0, 0, but we really don't know what it is. Now, we want to name the new place that he's at. All right, I'm going to color that place with a red star. We want to name this point. All right, this is how we do it. Okay, if we're going to translate 4 to the right and 4 down, okay, then we're going to take the 0 and we're going to add 4 to it. And we're going to take the 0 and we're going to subtract 4 from it. And we're going to end up with 4, negative 4. That's what our star is, where our red star is. That's the point right now. All right, now we want to translate again. All right, so I'm just going to erase up here. You probably have room, but I don't want to change my picture. I'm going to leave it just the way it is. Okay, that was our first step. Our second step I'll do in this pinkish color, our second step. All right, we're going to see what we need to translate. All right, so I'm going to go 1, 2, 2 up. Oh, I can't go up first, can I? I have to go left and right first. Yep, my bad. I'm going to go 1, 2 right. Oh, it just so happens to be the same. Okay. I'm going to go 1, 2 up. Okay, just so happen to be the same. That's a coincidence. What am I moving? I'm moving my XY point. Well, what is my point this time that I'm moving? Well, at first, my original point, I'll do it in green, was 0, 0. Now, my point that I'm moving is the 4, -4 point. Okay, it's where the star was a while ago. All right, so I'm going to translate 2 to my right and 2 up. So I'm going to take 4, I'm going to add 2 to it. I'm going to take -4, I'm going to add 2 to it and see where I end up. So 4 plus 2 is 6, and -4 plus 2 is -2, and that is my answer. They said, where's the bishop in relation to its original position? That is where the bishop is now. Pretty interesting, right? Chess game. Now, when I think of composing translations in a real chess game, I think of the knight. I'm going to do this in neon. Because the knight, for those of you that play chess, he goes up 2 and over 1. Or he goes over 2 and up 1. Or he goes down 1 and over 2. Okay? He's always jumping. And his is actually a composition of transformations in one move. Whereas the bishop, it took 2 moves to do this. All right. Example number 12 is actually the got it problem. It's from page 549, and it's the got it problem number 5. Okay? So I'm going to erase a little bit. Let me pause. All right, I'm back. Just had to erase a little bit because I'm going to do it up here so we can still see the same picture. We're done with example 11, and we're doing the example 12, which is the got it problem number 5 on page 549. All right, now let's remember where the bishop is now. He's at 6, -2. The bishop next moves 3 squares left. All right, so we're going to write this. It's translating. I'm going to go 3 to the left, okay, and 3 squares down. All right, so that's still going to be a negative, right? 3 down. And I'm moving a certain point. I'm going to put that point there. That's the point I'm moving, which is 6, -2. So I can erase this now. That's the point I'm moving. All right, so I'm going to translate -3, -3. And when I translate, I'm going to do 6 minus 3 and -2 minus 3. 6 minus 3 is 3, and -2 minus 3 is -5. Where's the bishop in relation to its original position? That's it. 3, -5. So you didn't know when you're playing chess or checkers that you're actually doing transformations. Now you guys don't look at this down here because I changed that for fewer problems. So what you're going to be doing in chapter 9 is you're going to be uploading all the got it problems that you just did, which means you're going to be uploading your notes if you just did that with me. If you're doing it by yourself on your own piece of paper, you may have wanted to go do the got it notes on a separate piece of paper every time we did it. But you don't have to. You can just upload your whole notes. Just make sure I can read them, please, so I can find them. All right. And then you're going to go do all the practice problems from the textbook. So I'm going to pull that up here. Geometry Honors. Pull that up here, and you can see here for Tuesday, April the 14th, we did these got it problems right here, okay? Pages 549 to 550, you're going to do 1 through 3, and then 7, 11, 13. I'm only making you do 6 problems, and then we're stopping right there, and we're not going to do the test prep worksheets like we were doing. After you do the got it problems and these 6 problems, you're done with the lesson and you upload all of those. All right, you guys, I'll try to do this again tomorrow. Have a good day, and I'll talk at you later. Bye.